Well, we're back at current sensing again. Only a little different way to do it is a specific chip that current senses for you and does a lot of the work internal to the chip. And what we're looking at there is the Max4080. That's the one that we're going to be playing with. And just to show you kind of you can go up to 76 volts. It's a high side. It's the one up by where you put the resistor up by the positive voltage. It's a high side current sense amplifier. And here's the package that came in from Maxim. And let's see if you can get that. Yep, that's the 4080 FASA is the type. And it's an IC op amp current sense. And it can go up to 250 kilohertz, but this one is not, it says that, but this one is not, this one is just single direction. This is not a bidirectional current sense. This would be like you're powering something and you just want to sense the current that's going through it. And you use the same methodology. You use the chip itself, and I'll show you the schematic here in a minute, but you use the chip itself and you have a resistor, a sense resistor, and when it senses the voltage across that resistor, and that of course represents the current going through the resistor, and then it takes it from there. And here's the pinout of the chip. It's very simple. It's pins 1 and 8 of the R sense. That's where the resistor goes across. It's got a VCC ground and then an output. And it does everything else in between. And let's look at some of the important things. And what I'm thinking is one of them that's going to become important. Oh, let me back that camera up just a little bit. One of them that's going to become important here is the voltage offset. If I can find that. Because I see an issue. There's an error being entered, and I'll show you this. But there's an error being introduced. Because I've kind of cheated. I've built up the circuit and been playing with it before I turned on the camera. And I see an error in it, and the error is within about 1%, but it's like, well, okay, but still, where's the error coming from? And I'm wondering if it's the voltage offset of it. And so I pulled out the data sheet. Of course, I was looking at it before, but I pulled it out here to see if I can find the voltage offset, input voltage offset. There it is. There it is. Let's see if we can focus in on that. Sorry about those lines on there if you can't, I hate the way that lines up. Lines up with the lines, get it? The input offset voltage. That is the voltage that is internal to the op amp. That is, you couldn't take a meter and measure this at the input of the op amp. You can't do that. This is internal to the op amp. It's internal to all op amps. And some are a lot worse than others. As we saw with the chopper amplifier, they have ways of taking that out or reducing it greatly to where you have a 0.5 to 5 microvolt offset. Most of them are in the millivolts, in the small single-digit millivolts. This one actually looks pretty good. It shows 0.1 to 0.6 millivolts. That's at a high voltage. It's at 48 volts. But anyway, we're operating at 5 volts on this one. But you see here. I'll get my pointer. You see here 0.1, I'm sorry, I was saying millivolts, percent. Sorry. It's too early in the morning for me. Voltage offset. This is going to be our temperature, 25 degrees centigrade. 0.1 to 0.6 millivolts, yes. 0.1 to 0.6 millivolts. We're not going to be operating up at that high, that low or that high a temperature. Plus or minus 1 millivolt. That still wouldn't matter. 0.1 to 0.6 millivolts. That may explain the error, and I'll show you the error that I'm getting that bothers me. So we go down. Let's look at a schematic. I know you want to see a schematic of this as we bypass a lot of the charts. Input offset voltage, histogram. There's a whiz down through some very important information. This is good detailed information on the Max4080 and its partner 4081. 4081 is for bidirectional current monitoring, and we're just one direction. So current monitoring with the oh gosh, poor cameramanship this morning. I apologize. Current monitoring with the Max4080. Let's see. Okay, there's the 4081, which is exactly like the 4080, except these parts right here are not on the 4080. These references, this reference right here, that's not on the 4080. The 4080, everything else is the same. Do they even show the 4080? We have one. Here it is, the 4080. They don't give the pin numbers, but those are easily derived. So you put your current sense resistor here across these two pins, and you have your positive supply here, goes through it, goes to your load to ground, and then you have an output voltage, and then you look at that voltage, and that shows, and that's going to be representative of the current that's going through there. And for your current values, well, what value resistor do you put there? Well, they have a chart that will tell you that. Now, I'm currently using a 1 ohm 1% resistor. That's the best I've got. And my load is less than 0.5 amps. So we're okay with that. According to the chart, we're fine with that. It has a gain of 5. So whatever voltage comes out of that out, the pin out, we have a gain of 5. Full scale V cents millivolts. Output voltage plus or minus 2.5%. See, that could be where our error comes from. I'm thinking it's the part. It is the part, because I've taken into account the resistor. And anyway, let me show you first what's going on. You've seen the schematic up here of it. Very simple. And let me show you what I did, because I ordered this. See, there's the 4081 again. They like showing that schematic. There's the 4080, which looks exactly like the one up there. So what we've got here is First of all, when you order this, you can't order it in a PDIP. At least I couldn't order it in a PDIP package. They didn't have that available. So a dual inline package was not available that's board friendly, you know, that's through-hole friendly. So I ordered the surface mount, and the surface mount came in this package that I showed you. Back up. Surface mount came in this package. These were very inexpensive, by the way, when I ordered them from Maxim. I did not get these as samples. Sometimes I get them as samples for free, but if you abuse that, they cut you off. So I try not to abuse it. I do every once in a while sneak in there and get a sample for free. And then they come in this package, and I ordered 2. You can see that. There we go. There's one. I'm using one, and this is one. So that's my one spare that I would have to do something else with. And I'll put that back together later. But what I used so that I could use it on a breadboard is something from Texas Instruments. A really neat little thing from Texas Instruments, so that I could turn this into, what I'm trying to do is get the package that it came in from Texas Instruments. Texas Instruments put this DIP adapter together, and what you see there's the glue where the pieces were stuck, the board was stuck on there. DIP adapter EVM, I guess evaluation module, and I believe they still have this for sale. And there's a picture of what you do once you solder on the necessary pieces. Once you solder your surface mount component onto their little board, which I'll show you, and then the headers, the pin headers, then you can put it into a normal breadboard. And there's what it supports. You know, SOIC8, TSOP, MSOP, and here's what it is we're talking about. This here. These boards here you get with it, and I don't remember how much this cost, but it wasn't much. You get these pieces with it, and then you find the one that fits your particular, like this one. I don't know if you can see how small it is. That one did not fit. See, this was too small, so that one didn't work. This one was too big for a surface mount, but the one that was just right, the Goldilocks, was this one right here, this top row here. Those fit the circuit, fit the 4080, Max4080 just right, and they're breakable. You break off one, and then you solder. You do a little SMD soldering, which is really easy. SMD soldering is easier than through-hole soldering to me. And this also comes with the kit. And then you break these off like 4 at a time and insert. When you get it done, you insert these in there. You solder those. You got them on both sides. Then you can plug them into a breadboard. And really cool little kit. I'm going to order another one from the DIP adapter EVM. I think you can get them from other places, but I like doing business with Texas Instruments if I can. They're good quality work. It's gold. Those are gold plated, not just tin plated. Those are gold plated circuits. adapter boards that they've got. So the circuit itself, let's take a look at that. I need a macro lens or something for this camera. I just can't get it to focus in on things from any distance. Let me pull this out of the way. This is just one that I'm measuring with. Here's the 4080 on top of the adapter board, which is also soldered to the pin headers. And then once those are soldered, I just plug it in the breadboard. And this is measuring the output voltage, which goes into pin 5. Pin 5 is the output voltage. Let's see. So, okay, here's what we got. Let's look at what our circuit is. We've got pins 1 and 8 right here. Pins 1 and 8. I didn't feel it necessary to draw a circuit because we had one. Basically, you saw the circuit on the diagram. That's what I've got. And it's just pins 1 and 8 are the current sense resistor. This resistor is my load resistor. And then that's really it. Then I've got power going to this side of the current sense resistor. Ground is here on this side of the load. So current just goes through the load resistor. I'm sorry, through the current sense resistor, through the load. And the current sense resistor is a 1 ohm at 1%. And then the output voltage comes out pin 5 out here, and I'm measuring that. And I'm also measuring what you see, this line here is I'm measuring the current that's going through, and let's take a look at that. When we look at both of those there, I think so. You see on the left, you see the current as measured by the meter is 344.6 milliamperes, and I think the load resistor is like an 8.2 ohm resistor, and as I mentioned, the current sense resistor is a 1 ohm 1% resistor. But really what's more important here is what current is it seeing, and how accurate is that. And so we see 344 milliamperes, 0.456 there, and what we're seeing there on the right is 1.238 or 1.24 if you want to round it up volts. Well, we know that since it's a 1 ohm resistor, and we know Ohm's law, 344 milliamperes is going to equal 344 or 0.7 milliamperes is going to equal 344.7.8 millivolts. Well, and we know that this particular chip, this 4080, it gives an automatic gain of 5. You can't alter that. Is a gain of 5. Then you multiply 5 times 344.7 and you should get the voltage at the output. Well, when we do that, and I won't show you the calculation or the calculator. You know, you've seen calculators before. 344.6 we'll say times 5 equals 1723, and we're getting 1.22. Well, that doesn't make any sense. Sorry, I had to check my arithmetic there. What we're getting is 1722, sometimes 1723, depending on where it's floating around. And what we get as an output is 1.75. I have to confess, I had that stuck in the wrong pin. I had it stuck in pin 6 instead of pin 5 of the voltage monitor there, the multimeter on the right. So now we're looking at the correct one. We get 1.75 volts. Our calculations show that we should be getting 1.72 or 73 volts, and we're getting 1.75 volts. Now, what is that in error? If we subtract that, 1.753 equals divided by well, it's a 1.7% error. So if we remember back on the page where it said there was going to be an error of so many percent, what was it? See if I can find it again. Our gain accuracy is plus or minus 1%. Well, 0.1 to 0.6% actually at our temperature. And our millivolts offset is 0.1 to 0.6 millivolts. And so we do have error there. We do have error in that 1 ohm resistor is not exactly 1 ohm. It's could be just a little more or a little less. It's a 1%, and so I think we're within 1.75% of the. We're say we're within 2%. We're within 2% of the overall error of the accuracy. We're within 2% of what would be exact. So I think we're okay in terms of that, but it still bothered me that we have that error. And plus I wanted to show you another way to measure current using a device like the Max4080. It's a real good device. Very few parts. You know, you do have to do the DIP thing unless you have an SMB board and you design it yourself. You do have to do the conversion to DIP with the dip adapter. But if you want to just put that together and have a good current sense monitor without having to do the differential and worry about the resistor values and getting those right and all of that, all that's internal to this chip and has been trimmed. And so at least you get between I would say between 1 and 2% accuracy is what I'm seeing on this. And I put several values in here, and I'm seeing about the same accuracy with all of them. And also we can't forget about the burden voltage of my multimeter that I've inserted into the thing. It's introducing another value, an ohm value in there, and may be causing some error itself because it has its own internal resistor that it measures the current with. Because we're basically measuring the current with two devices right now, one with the multimeter and one with the circuit, my circuit. And the multimeter has its own sense resistor too. So I guess this wasn't meant to be a long video on it. It was just meant to show you another way in which you can sense current. And you can now take this voltage, this 1.75 volts that you see, and you can run that over to an Arduino, as we've seen before, into the analog 0, analog 1, one of the analog adapters. What I'm going to do, there'll be a follow-on to this video where I have a 16-bit converter, and I want to convert this into 16 bits and then put that into the Arduino. I think that'll be interesting. I don't think there's anything interesting or to gain by throwing this into A0. We know how to do that, and then just read it, and it will read it in we'll get a 2 decimal point accuracy anyway out of it, and it's just not that exciting. I just don't think we're going to gain anything by that. I think the important thing here is that there's other ways to sense current, and this is a very good way to do it. There's lots of current sense chips out there. TI has them, Maxim has them. At the time I bought this one, my particular needs were for the Maxim. I think this is when I was building a power supply. One of the several times I was building a power supply, and I was trying out. I had ordered different chips to try different chips to see which one worked best. And this one was a good one because it feeds back a good voltage back to the controlling processor, so that it can get a read on what current is going through, what current is passing through, so they can limit it, or just know what it is, calculate the watts, whatever you want to do with it. And but anyway, that's the really where I'm going to end the video, and I hope you enjoyed it. You get the 4080 and you can start playing with it, and you can see it's very simple to build up and monitor what current is there. But anyway, I hope you liked it. Thank you. Well, one thing I didn't show you was the DIP board that I showed from Texas Instruments. So they sell a bunch of them, and then you just pop off what you need, and then you insert these headers. You solder these headers on. But there's the board and the chip, and you solder the chip in, and it's real easy. And then you put these pin headers, you stick them down into a breadboard, and then insert the little green board through them, and then you solder those in, and then you have a nice adapter. You have an SMD adapter. But I just wanted to show you that up close. That's the 4080, the Max 4080 current sense.